Hi everyone, welcome back after a while. So today we are going to build simple yet powerful machine learning model, a shallow neural network using Python and TensorFlow. So we are going to classify handwritten digits from MNIST Dataset. So let's dive right in. So for being able to run this one, you can either run this on the Google Colab or you can have TensorFlow and Python installed on your system. And with that, let's dive right into the program. So we are going to import some libraries, as you guys can see, NumPy, then TensorFlow, and Keras dataset. We're importing MNIST dataset, and we're going to use NumPy for numerical computations, TensorFlow for building our network, and yeah, dataset is our MNIST dataset. So the next block is we're loading MNIST dataset where we are training X and Y and then testing X and Y and keeping those in the variable mnist.load data. So we load the mnist dataset containing the images and handwritten digits and their corresponding labels. We normalize error pixel value by dividing them by 255. That's what it is needed to normalize, or we are going to run out of the memory, and that will be not good because we have limited compute, and that's really important to normalize the pixels, divided them by 255. That ensures that all input features lie between 0 and 1, making that easier for our neural network to learn. We reshape the data to fit our neural network model. In this case, we're expecting images of size of 28 by 28 pixels. So that's what it is happening in here right now. So uh, now we downloaded the data and we are creating the model now. So let's build this simple shallow neural network with one hidden layer using TensorFlow and Keras API. So as you can see, module equals tf.keras.sequential, tf.keras.layer.flatten, then layers.dense, then layers.dense. This is what our basic model looks like. So as you can see, 128, and the activation functions we are using as first one is the ReLU and the second one is Softmax. So as you guys can remember, we have been through the both of activation functions, how those functions work mathematically before in the previous videos. So firstly, the tf keras layers flatten function. This layer takes our 2D input images like 28 by 28 pixels, then it transforms them into one-dimensional array with 784 elements. That is like 28 into 28. Then after that, tf.keras.layers.dense 128 comma activation equals ReLU. That thing is our hidden layer containing 1828 neurons or nodes, where we use the rectified linear unit ReLU activation function here because it helps us alleviate the vanishing gradient problem and it speeds up training. And then we train the tf.keras.layers.dense chain activation where we are giving the softmax. So our output layer contains 10 neurons, one for each digit class 0 to 9. So we use softmax activation function to produce probability distributions over our target classes. So that's how it is. And then we are compiling our module in here with using the some optimizers like Adam. So we choose Adam optimizer algorithm, which is really amazing at for a lot of problems. So there are a lot of optimization algorithms, and what is optimization? That's that's going to be a topic for other video, but that's like super cool thing. So I'm going to explain optimization in like a really small little uh little moment. So imagine like there is like a mountain, and normally if you throw some like tennis ball or something on the mountain, then the normal thing the ball might be doing is trying to like roll downwards from the slope of the mountain. So that's what our uh, gradient descent function does in our mountain problem. But normally, sometimes what happens is if ball goes into some local minimum state, like some small trench, not deeper trench, but small trench, and it settles there, then it's difficult for a ball to go to the like deeper one. So it cannot go to uh, other. So that's our vanishing gradient problem. So that's what we deal with stochastic gradient. So all these concepts might seem new, but believe me, we are going to go through all the things. Those are really amazing things. So uh, moving forward, we use sparse categorical cross entropy as our loss function because it's suitable for multi-class classification problems with integer targets like our digit levels. We monitor accuracy during training and evaluation to see how well our model performs. And then we train our model here. So as you can see, we are performing 5 epochs. So we pass our training data X-train and Y-train to the fit method. So what exactly happens in the fit method is we try to fit. So function is a fitter model or optimizer, like our model which is using optimizer to fit the model thing to how it's the function is there. So imagine uh, there is a sine function, and we can fit our model how it performs into the sine function somehow, and that happens with the fit like optimization techniques and all, and we train the model. So it is the best possible thing that we can predict how the exact data might be. So for in this our examples, we are going to pass our training data to fit method. We are going to specify that we want to train 5 epoch full passes through entire dataset. We are going to provide test data X, test and Y test evaluation data, allowing us to monitor model performance on the unseen data during training. And then we are going to evaluate our model performance on the test data. So that's our test loss thing which we are going to do. Then we're going to pass our test data. So basically, uh, X test, Y test to the evaluate method. This method returns the loss and accuracy metrics for our model on the test data. And we're going to print out the test accuracy so you can see how well our model performs. So finally, let's make some predictions. So what's predicting our model is predicting here? We pass the test images X test to the predict method. The method returns an array of possibilities for each digit in our target set 0 to 9. We use NumPy's argmax function to determine which class has the highest probability and return that as our predicted digit. So, and that's how you build, train, evaluate, and make predictions between a shallow neural network using Python and TensorFlow. I hope this tutorial helped you understand each step along the way. If you find this video helpful, please give it thumbs up and share with your friends, and don't forget to subscribe for more cool tutorials like these. And you're going to find the code for this in the description and how to run your code. And yeah, be sure to understand each and everything that is happening in the code. And yeah, code is all yours, guys. So with that, happy coding, keep grinding. See you in the next one.